Hello everyone. In this video, we are going to pick up from where we left off in our last video on brute forcing login forms using Python. In this video, we are going to make our script even more powerful by using multiple threads and making it even faster. So first, we are going to begin by discussing about multithreading and queues, since we are going to be using them, and then we are going to implement them in our script and then test it out against our target. And lastly, we will also look at how we can protect ourselves against such attacks. So let us now talk about multi-threading. First of all, what is a thread? A thread is a path of execution within a process. Put simply, it is just a set of instructions which can be executed independently by the CPU. When a process runs multiple threads, it is called multiple threading or multi-threading, and it enables us to do tasks faster. But if you take a closer look at multi-threading in languages like Python, you will see that at any given point of time, only one thread is running. So how does this increase our execution speed or decrease the time taken for the program to execute? Let us take a look at it now. So how does multi-threading actually speed up execution? Multi-threading enables faster execution for a program if it has to wait for some external signal. Let us take the example of our previous program where only one thread is running at a time. It first attempts login as password 1, then it has to wait for a certain amount of time while the server receives the request, processes it, queries the database, checks for the correct password, and then sends us back the response. So there is some time where the thread has to wait. And this time gets accumulated as we try more and more passwords, and it becomes quite a large amount time wasted. Now let us take the case where we have multiple threads running. So on the screen you have a diagram where two threads are running, thread 1 and thread 2. So thread 1 attempts login as admin and password 1, and then it is waiting for the response from the server. In the meantime, we create another thread, call it thread 2, and it attempts password 123 exclamation mark. Now thread 2 has to wait for the response from the server. So we pass the execution back to thread 1, and as soon as thread 1 receives the response, it starts to process it. And as soon as thread 1 is done, we pass the execution back to thread 2. Now thread 2 would have already received its response, and as soon as it gets execution, it starts to process the response. And this way we waste no time waiting for the server, and we just keep executing our code. And this greatly speeds up the total time our program takes for it to execute. Since we are using multiple threads, we need a way to pass data between the main thread and the other threads. For example, the username and the password to try. We need to be able to pass this to our worker threads. So in Python, we can use the queue module, which implements queues with proper locking mechanisms, which will enable us to share the data between the threads. So now let's start actually coding this. So I have my Kali set up, and in the background I have metasploitable running. Machine is 10.0.2.6. So now we can switch back to Kali and open a new script, multithread.py, and our previous script brute.py, which we created in our brute forcing video. So first we copy the shebang line over, then the requests module, and we need to import a few other modules. So the first is going to be threading, since we are going to make a multi-threaded program, and to communicate between those we will need queues, so we import the queues module. Next we will need the URL, which is going to be the same since we have the same target. Simply paste it over here, and the IP is same, 10.0.2.6, and this is the path to which we will post our data. Then we can copy the users, but we will not copy over the passwords, because for the multi-threaded program to actually function and to be able to benchmark this program, we need to provide it with a big list of passwords. If we supply it with only 3 passwords, it will be of no use because the overhead associated with creating multiple threads will outweigh the advantages multiple threads offer. So instead of having a list with less passwords, we can use a common word list. In here I will be using RawQ. So if you are using Kali or Parrot, it should be present in user share word list and rawq.txt. If you have not unzipped it before, it would be a gzip file as rawq.txt.gz. You only need to do sudo gunzip on that file and it should inflate rawq.txt. So we can go ahead in Python and open it in read bytes mode, and we can say that passwords is f.readlines, and we can print passwords. Let's print the first 10 passwords, and we need to also close the file. So chmod +x multithread.py, run it, and this is a pretty big file. So these are the first 10 passwords, and you can see that there's a new line character at the end of each, so we will have to make sure to strip it before sending it in our request. So we can delete this print statement and we have our passwords. Next we have the cookies, and the security low we can leave as is, but we will need to change the session ID. For that, first we will have to fire up Firefox and navigate over to the damn vulnerable web application on Metasploitable. Log in with admin and password. I can make this visible quickly, and I can change the type equal to password. So admin:password, login, and now we need to just copy the session ID. So the PHP session ID is this, and now we come to the backbone of our application, that is the brute forcing part. So since we are going to be doing a multi-threaded brute force, we do not want to see this output of trying this because there will be a lot of overhead associated with logging std out. So we can simply copy this payload and this part and create a test login function with given username and password. This function can be called by multiple threads, and it would simply test one login with the given username and password. So we can change this username and password is password, login is login, request is URL plus payload, cookies we have set, and if it is not incorrect, then we print valid credentials form. Now in this case, for debugging purposes, we can try test login function. We can also put return true, else return false. I did not put an else statement because if it does not return from here, it will automatically get here. So we can simply test login for admin and try this out. We get false, that this login does not work. So admin password, and we get user is not defined, which means I missed something, and this is username, and it also means that it did reach this block of code. That means this user admin:password works. Now in this case, I already knew that this is a valid combo, and so for debugging purposes I just add this check. But if you do not know the correct password, this function would always return false. Now we can move on to creating multiple threads. So a thread is creating by threading dot thread, and target is equal to with the function which we want to target. So let's say test login, and if we want to pass it any args, and this needs to be a tuple, so this should be our tuple, admin colon password, admin and password, and put in a comma just for good measure to keep it a tuple. And we can say that this is our thread, and then we need to start this thread, and then we need to wait for it to finish. So t.join. Let's run this program, and we see valid credentials found. That means our thread was created and it worked. Now what we need to do is create multiple threads with multiple passwords. So first of all, creating multiple threads. But before we do that, let us implement a worker thread function which takes a queue, which will just call it queue, and then our queue will have all usernames and passwords as tuples, and it takes one set of username and password off of it, tries that login, and if it is correct it prints it, and if it is incorrect, then it just continues on. So first we will need to initialize the queue. So let's say queue is equal to queue dot queue, and while queue dot length is greater than 0. So till the time we have something in the queue that we need to process, what we are going to do is queue dot get, and this is going to be a tuple of username and password, so we can retrieve it like this. And for now let's simply print username and the password. This is a shorthand way to print username equal to username and password equal to password. And with this we can do queue.put admin password, and this has to be a tuple, and call worker thread function without creating a new thread. And forgot to send it the queue. Queue.queue size greater than 0. And now if we run this, this should work. So we have username admin, password. And for good measure, we should also make sure that we strip both username and password, because our passwords always contain a new line. So let's just make sure that we strip the new line off of both of them. So username and password we have stripped it, and now what we need to do is simply test the login for username and password. That's all. So let's test this out. We are going to put in let's say root and admin, and let's keep ours in here and test this out. Right now this is only a single thread, and this is only a single thread program. So let's add a multi-threaded functionality to it. Our target is going to be a worker thread. Arguments is going to be a queue, and let's start 2 threads and then wait for the second thread. And this is still working, means we did not mess anything up. And now what we need to do is use the passwords from the word list, put them in the queue, and then start the threads. Now ROCU is a very humongous word list, so if we wait till all passwords are added to the word list and then start brute forcing it, it's going to take a lot of time. So what we do is first add 1,000 passwords to the queue and start the brute force, and in the meantime we keep putting more items to the queue, and the workers keep processing it. So for password, in first let's try for user, in users, I think it's users, it is users, and then for password, in passwords, q dot put a tuple of user comma password, and this passwords. Now I do not need to strip it over here because it is stripped inside the worker function. Now this is going to take the user first, let's say admin, then try all passwords for admin, then it's going to take the another user, let's say root user, and then try all passwords for that user. This is the brute force attack, but a better way to do this would be to use a password spray, that is reverse the order of these loops. So the for every password that you get, try every user, so there is less chances of you being blocked by the web application, and for less chance for the user account to get locked. And if this brute force attack works on a website, then that website really needs to secure itself. So we put all this in the queue, and if let's say queue size becomes greater than 1000, then what we need to do is start the threads. So let's create a function start threads, and this should work. Now we also need one variable to keep track whether the threads are already running or not. So we can have a thread started variable and keep a check here that threads not started. So let's now implement the start thread function. So start threads, and let's keep a global variable called threads, which is a list of all the threads. So for underscore in range, let's say number of threads, how many threads we want, and let's take our code from here, paste, and what we will do is instead of t dot this, we will do threads dot append, that is add to the end a new worker thread, and threads -1, that is the last thread, dot start. So that will create this many number of threads and start all of them, and at last we can set global thread started, and thread started is equal to true. So this will start all threads, and I think that much should be enough. We can now try and run this program, just making sure that admin is the first user, else it will take ages for this demonstration, because I know that admin is the correct user, else it will not matter that much. And start threads is missing required arguments, so let's take 10 threads. And for good measure, I should also put threads started. So threads are started, and I am hoping this is the global queue. Good, so it should have worked by now. So for debugging, not thread started. Wait a minute. For debugging, simply let's just put testing username colon password and an f string. Let's run this now. So it is trying those different passwords, and if you notice the problem here, when Python concatenates those strings, it will have this b before it because it's a byte string. So we will have to decode that as Latin 1. Latin 1 is because of this word list. The Rocky word list contains some special characters too, so if you decode as something UTF-8, it starts to fail. So the B has disappeared, and I'm just going to force kill this, remove the debug statement, run it, and we instantly get valid credentials admin colon password. So this is really faster than the simple rbrute.py script, and if you use a large word list like rocku.txt in this single threaded script, it will take ages to run, whereas this script will still run comparatively faster. Instead of 10, you can also have more than 10 threads, like let's say 20 threads, depending on how much the server can handle. I think 20 should be okay for it. So that is that. Next, how we can protect ourselves against brute force attacks. So the first thing is to have a strong password policy. If you have a stronger password, then there is a lesser chance of it being guessed by the attacker. Next, have an account logout policy which, after some n failed login attempts, bans the IP address and logs out the account. So for example, if in 5 minutes there are 3 failed attempts for my account, then log out the account and ban the IP address from which these attempts were made. So this will significantly slow down these attacks. Next, use two-factor authentication and CAPTCHAs. Now, two-factor authentication requires the attacker to have access to the physical device, which in most cases does not occur. So this will stop brute forcing attacks, and CAPTCHA requires attackers to have some kind of image processing abilities, which significantly makes it harder for them to brute force passwords for accounts. So thank you for watching. The code that was written in this video will be available on GitHub, link will be in description, and if you have any questions, feel free to reach out to me. Thank you.